it is when the rocket ship goes on up with people in it. It was honestly really fun doing it and learning like how they feel at the moment.
And Denim, what do you think it will be like to watch the world's most powerful rocket launch tonight from just across the river?
Well, really, I don't really know what to expect because I've never really done this before, but I feel like it would really be outstanding. I might shed a little tear, but I don't really know. Like, I'm really excited to be here, and it's amazing. Like,
It is amazing, and I don't think you're going to be the only one shedding tears tonight. Megan, we're super excited, eyes on Artemis, and we're ready to see the launch.
Thanks so much, guys. Now, Kayla, are you ready for more questions from social media? We're getting them in.
Always.
All right, let's take a look at the screen now. We have another celebrity question.
Hey, I'm Kiki Palmer, and I play Izzy Hawthorne in Pixar's Lightyear, and I can't wait to see Artemis 1 launch today. How will going back to the moon pave the way to Mars?
Thank you, Kiki.
Yeah, what an awesome question for tonight. I mean, the return to the moon is going to give us a chance to test all of the capabilities we need to operate on Mars. Mars is really far from home. It's going to take us 6 months just to get there, and that's with ideal planetary alignment and expected advances in propulsion technology. Then we'll spend about a year plus on the surface before it's 6 months home. And so the moon is a lot closer. We can get there in 3 days. The communications delay is a lot shorter, and so we can really test our operational concepts a lot closer to home. The moon's super far away. It's 250,000 miles, but that's way closer than Mars. So it's going to give us a chance to test all of our technologies so that we know what we need to develop in order to take that next step.
Yeah, we call it the next giant step for a reason. Mars is very, very far, like you said. All right, let's take another question from social media. Kayla, what inspired you to be an astronaut?
You know, my journey was a little bit different than some of my colleagues. I didn't grow up specifically dreaming of becoming an astronaut. I don't know what the barrier was there. I was aware of and inspired by the space program, but I never allowed myself to dream of becoming an astronaut until I had served on a submarine, actually. I think that operational experience that's so similar to what we do in the space program, if you think about it, we're sending humans to live, work, and do something of importance in a place where people aren't supposed to be, the depths of the ocean or the vacuum of space. And so I think those experiences gave me the confidence to even dream that I could become an astronaut, and then inspired me to apply in the first place.
And that doesn't deter you, again, like being in a place where, we're not supposed to be, a confined space at that.
Yeah, I think those parallels, I got a chance to meet an astronaut after serving on my submarine, Kay Heyer, who's also a Naval Academy graduate, class of 1981. And hearing about her experiences working on the space station really made me click. All of a sudden I said, the space station's a submarine in space.
Yes.
And it sounds silly, but I had never made that connection before. And once I did, I just couldn't stop dreaming about it.
Oh, that's so cool. I love that your story isn't, the typical one, as you said. Okay, I think we have time for one more question. Is Snoopy ready and excited?
Of course. I think like any crew member, Snoopy's been training for this moment. He knows what to expect in a nominal and an off-nominal launch and all the actions expected of him. So like any good crew member, he's ready to go.
And he has a suit that's been tailored to him. It's especially made for him, the way that the astronaut suits are especially made for them. So yeah, I think he's ready.
Yeah. Seeing the moon up close, he's ready to go.
So keep those questions coming. Use that hashtag Artemis and tweet or drop them in the comments wherever you're watching this broadcast. And don't forget those NASA Moon Snaps. Hashtag NASA Moon Snap for your moon-inspired content. Okay, we are now 37 minutes from the opening of our 2-hour launch window today. Let's check back in with Daryl with the launch team.
Yeah, we've had a couple of issues that the launch team has been working, and we have an update on both of those. First of all, is the leak, the liquid hydrogen leak in the replenish valve out at the mobile launcher. We understand from the launch team that that leak has not recurred. The work that happened out at the pad is that the red crew and the work that they did out there remedied the leak. That's good news. And now the liquid hydrogen tank on the core stage is back in replenish at this moment. And the upper stage of the rocket, liquid hydrogen side, is in fast fill. You can see from the graphic there that we are back up to 100% over on the liquid hydrogen side on the right hand of the screen. On the left hand of the screen, you can see we have been in stable replenish for liquid oxygen. Now, with regards to the range, they reported that they had an issue to the NASA test director with their radar sight. Later found out that that was actually a bad Ethernet switch that was cutting out and not providing them the data. The range reported that they will swap out that bad switch, and they're currently working on that. They advised at the time, about a half hour ago, that it would take them about 70 minutes, or about 25 minutes into that work. They did just recently update the NASA test director to say that it's going to take them a little bit longer because they're going to need to re-verify this Ethernet equipment once they have it installed. Again, that work is ongoing, but at the moment, if we were launching right now, the range is no-go as a result of that bad Ethernet switch. The Dolly-Lu file, which helps steer the Space Launch System through the upper atmosphere, has been uploaded to the rocket, and so we're good to go there in terms of other configurations that are ongoing. But we are continuing to monitor communications of the launch team about holding to the top of the window, currently slated for 1:04 a.m. Eastern Time. But we do have 2 hours, and we have yet to see whether or not the launch team is going to be able to make enough adjustments in order to hit the top of that window. No slip yet, but we're monitoring their work, and we'll give you an update when we have it. Back to you, Megan.
Thank you, Daryl. Really great news about that leak. Kayla and I actually said, wow, that's really great news. So we'll wait on your next update. Let's go back live now to Kennedy Space Center's visitor complex, where we have NASA's Dan Hewitt inside there with our new moon board. Dan, let's focus in on Orion now. It has 3 main elements, right?
That's right, Megan. And Orion is the spacecraft that's going to be carrying our Artemis astronauts off of planet Earth and then returning them home. As you said, 3 major components, so we'll jump in here at the top with the first one, the launch abort system. This is a critical safety feature on Orion, designed to pull the capsule away from the SLS stack in the event of an emergency on the pad or the way uphill. And it does that using 3 solid rocket motors. The first one, the abort motor, can fire within milliseconds of automatically detecting an issue, pulling the capsule away to a safe distance. After that, the attitude adjustment motor. This one will fire. We can cancel out any rates, put us into a nice stable glide before we get ready to fire the jettison motor. This is the one that will actually take the launch abort system off of Orion, allowing it to then deploy parachutes and parachute down to safety. I will note the jettison motor, the only one that fires no matter what on a normal mission. It's going to fire once we're high enough in the atmosphere. And for Artemis 1, that is the only motor on this that is active. The attitude and abort motors are inert for Artemis 1. And that's all focused on protecting this, the Orion crew module. This is where you have your astronauts physically inside. In the capsule, you have everything you need to keep a crew safe, happy, healthy, thriving in deep space. You have a pressurized environment, seats, crew displays, toilet, everything that you need. On the outside, couple of critical features. On the bottom, the heat shield. Remember, this is goal number 1 for this mission, is testing that heat shield. It's an ablative structure made to survive that fiery reentry at the end of a mission. Along the outside, you see these small gray circles. Those are reaction control system thrusters. Orion can use that at the very end to control the yaw, pitch, and roll as it's hurtling through the atmosphere. We have windows. You need windows to look outside. 2 on the front, 2 on the sides, 1 in the side hatch, 1 up top in the very top docking hatch. Those are different layers of glass and acrylics for pressure and thermal control. We have a docking system, an uprighting system, parachutes, all for the very end of the mission. Third and final piece, down here at the bottom, the European Service Module. This has all of the propulsion assets for after SLS has done its job. Starting on the bottom, the large orbital maneuvering system engine. This is the one that's providing the most thrust for all of those key maneuvers around the moon. 8 auxiliary thrusters also around the aft to the bottom part of the service module to provide some additional push as well. And then 24 of these smaller reaction control system thrusters. They can be used for attitude control, which way you're pointing, as well as small translational maneuvers moving side to side. We flip the vehicle up, we see 4 solar arrays, each one 24 feet in length, altogether generating 11 kilowatts of electrical power for Orion systems. Inside the service module, you have tanks for things like the thermal control system, potable water when we have a crew on board, and also pressurized atmosphere, which gets fed through this umbilical here to the crew module along with electrical lines. That's also what's going to separate us at the very end of the mission. So that's Orion. It's going to be making its first flight around the moon on Artemis 1. Can't wait to see it, taking those selfies around our lunar neighbor. Send it back over to you, Megan.
Thanks, Dan. That last component Dan talked about, the European Service Module provided by the European Space Agency. Let's go to Jasmine for that.
Thank you, Megan. We are back in Firing Room 2 with the Launch Control Center, and joining us now is Philippe Delou, ESA's Program Manager for the Orion European Service Module. You have quite the title there, a big title for a big job, I'm sure. We are very glad to have you here, and we understand that the European Service Module is powering Orion that's going to send humanity farther than ever before. Philippe, how is it getting us there?
Yeah, thank you. Good evening, everyone. So yes, the service module accommodates the propulsion system that contains among the tanks and the pressurization of the system the engine. All the engines, 33 engines in total, among which the main engine, which is going to perform the burns to put Orion into the moon orbit and then back on the trajectory to return to Earth. The other engines are used for attitude correction during, attitude control and trajectory correction during the travel to the moon. In addition to the propulsion system, the service module generates the power and distributes the electricity to the crew module and the service module equipment so that they can operate. And the third function is the thermal control of the system. The service module accommodates radiators to reject the heat that is produced by all the equipment and the crew that will eventually be in the Orion. Finally, not on Artemis 1, but on future Artemis mission, it will have tanks to store the crew consumable, the water, the oxygen, and the nitrogen.
Right. So we understand, too, that you are monitoring launch here in Firing Room 2 with us. And you also have a team. We're going to bring up a picture of that team right now, or a live look inside ESA's control room in the Netherlands. So can you tell us, what is your team working on today?
Yes. Well, the ESA team is not only back in the Netherlands, it's one aspect, but we have also a significant team in the control room in Johnson, in the Mer control room. And their role is to monitor the telemetry from the service module to make sure that all parameters are within their nominal behavior, that the operations are performed also nominally, and for sure identify if something goes wrong, if something goes not nominal. And if something non-nominal is identified, then they will have the role to support the NASA team to troubleshoot the anomaly and prepare the recommendation to be brought to the mission management team for a decision on how to operate the vehicle forward.
Great. We're really glad to hear that your teams are monitoring here, Johnson in the Netherlands as well. And this has been a huge collaboration. There were 10 countries that contributed to the European Service Module. Can you tell me about that teamwork?
Indeed, it was a real teamwork of about 60 companies across 10 European countries. Together with the prime contractor, we have selected the finest companies available in Europe to build the state-of-the-art equipment which is needed to go back to the moon with humans.
Right, we're going back to the moon and farther even beyond. Thank you so much, Philippe. I really appreciate you being here tonight.
You're welcome. Thank you very much.
Of course, of course. Megan, back to you.
Now it's time to check back in with Mission Control in Houston. Leah, how are things over there?
Things are good over here at Johnson Space Center, which is just one part of an agency-wide effort with many NASA programs doing their part to make future missions a reality. When the first woman and first person of color travel to the moon, they'll be wearing a state-of-the-art launch and entry spacesuit called the Orion Crew Survival System. When they set foot on the moon, they'll be in another all-new next-gen suit, both being developed at the Johnson Space Center and through partnerships with commercial providers. During those spacewalks, astronauts will collect samples for further study of the moon. The Astromaterials Research and Exploration Science Division at JSC is preparing to receive rocks, soil, and ice collected from the moon's south pole, which has a unique crater impact history and ice deposits that have never been sampled. And leading the effort to advance capabilities for science, exploration, and commercial development of the moon is the Commercial Lunar Payload Services Initiative, or CLIPS. More than a dozen American companies are developing science investigations and tech demos. Additionally, we need a sustainable presence, a specific station in orbit to facilitate continuous lunar access and serve as a home base or a jumping off point for new deep space exploration missions. This is where Gateway comes in. It's a multi-purpose lunar space station being developed by a worldwide effort led out of JSC. NASA is again teaming up with international and commercial partners to create this essential component. Artemis and Gateway will enable NASA's Human Research Program to better understand how the human body adapts beyond low Earth orbit, ensuring future astronauts traveling to the moon and Mars have the tools to keep healthy and thrive in new environments. And with that, we're going to turn it back over to Megan and Kayla at Kennedy.
Thank you so much. So Artemis will also facilitate new discoveries about the moon. So to tell us what we're hoping to learn, we have Sarah Noble here. She's the Artemis Lunar Science Lead. Great to have you here.
Thanks.
So tell us about what we know about the moon.
Yeah, so we learned a ton about the moon during Apollo, right, from the samples and the data that we collected. In fact, we're still learning from those samples and data even today, 50 years later. But then since Apollo, you know, we've actually been studying the moon mostly from above, learning about getting more of a global perspective on the moon that we really didn't have during Apollo. And so that's allowed us to ask a lot better questions and to understand where to go to find the answers to them.
Now that we're headed back to the moon, sending human beings as part of the Artemis program, what are we hoping to learn that's new?
Yeah, so we're going to an entirely different part of the moon for Artemis, right? During Apollo, we kind of landed almost in the same place, like 6 times, right? In the sort of central near side of the moon. But for Artemis, we're going to go explore a new part of the moon. We're going to go to the South Pole, which is some of the oldest rocks on the moon. It's the part of the original crust of the moon. And there's places there that are permanently shadowed, where we think that water and other molecules sort of get trapped, and we really want to understand what those are, and so that we can use them for both science and for as a resource.
Sarah, we're also planning to land a rover at the South Pole of the moon in late 2024. Can you tell us about that?
Yeah, absolutely. The Viper rover, the Volatiles Investigating Polar Exploration Rover, is going to go land near the South Pole, and it's actually going to explore some of these permanently shadowed areas. It's going to dip into them, drill down, try to find out what that water is, what else is there, what form that water is, how much is there, so that we can really understand it both from a science perspective, and if we want to use it as a resource, we will understand how to extract it.
So some people might say, you know, we have all these rovers, we have access to machines that can do a lot of the work on the surface of the moon for us, so why is it important to return humans to the moon?
Yeah, it's not an either-or proposition, right? There are some things that robots are better at and some things that humans are better at. And it turns out that humans are much better field geologists. We're really much more efficient and better at that. Plus, we can do better. We can deploy more complicated instruments, and we can use tools in ways that it's very difficult for robots to do, so we can collect better samples. And one of the great things is that we can bring back a lot of samples, right? When we do robotic sample return, it's usually a very small amount. But if you look at what we brought back from Apollo, it's a large amount of samples that literally hundreds, probably maybe thousands of scientists have been able to study over the years and over generations. And that's a lot of brain power to put behind those samples.
So again, that's how Artemis and Apollo are different. Now we're utilizing machines and people.
That's right.
To hopefully advance. Yeah.
That's right.
Perfect. Sarah, thank you so much for your time.
Thanks for having me.
So in honor of our destination, the moon, we asked you all to create moon-inspired content and share them with us using the hashtag #NasaMoonSnap. We got so many wonderful submissions, so why don't we check them out now? That was a really cool look at all the different kinds of creations, recipes, and also art, and it was great to see what people submitted.
Yeah, it's awesome to see the creativity out there and how people are engaging with this mission in so many different ways.
Yeah. So I know that you didn't submit it yet, but you did create a moon snap, so to say. So why don't we take a look at that picture?
Yeah, this is one of my favorite pictures of the moon that I was able to take from orbit. I think for me, it kind of reminds me of that iconic picture of moonrise or Earthrise from the moon from Apollo. And it's kind of that in reverse. I think there's something about seeing the moon from orbit around the Earth that makes it seem a little bit easier to imagine what it'd be like to have that view from the moon looking back at our home planet.
Yeah, you should definitely submit that because that's an amazing photo. Did you take that yourself?
Yeah, out of the cupola window aboard the
Wow.
space station.
Wow, the resolution's great.
The cameras we have up there are incredible.
Yeah.
It's awesome.
So I haven't taken a moon snap, so I had nothing to submit. So how do you feel about creating a moon snap with me?
Let's do it.
All right, well, take that, if you don't mind lifting it up, and we're just gonna snap a photo here. Oh, lighting. Perfect. So I just created a moon snap. I love it. I'm going to share it. And again, this is just to encourage people to really get involved in this mission. So we will continue to collect and share those photos. So again, if you have a NASA moon snap, just use that hashtag. Okay, Artemis 1 comes amid a very busy year and exciting year at NASA. Some of the highlights include 2 more commercial crew launches with SpaceX, Crew 4 in April, and then Crew 5 last month. In May, NASA and Boeing flew OFT-2, the second uncrewed flight test of the Starliner capsule. The goal is to certify the capsule for regular flights to the International Space Station after a crewed flight test next year. In July, we released the first images captured by our James Webb Telescope, and oh my, those are really beautiful, fascinating photos, and they're going to really help us answer some of astronomy's biggest questions about how our universe began. And then in September, we intentionally slammed the DART spacecraft into asteroid Dimorphos. Boom, look at that. And we successfully changed its course. The asteroid wasn't headed for Earth, but the test was to show we could defend our planet if needed. And recently, 2 other missions that benefit the Artemis program. Last week, we tested a new inflatable heat shield that could help us eventually land humans on Mars. And just 2 days ago, Capstone arrived at its intended orbit around the moon. The small satellite launched from New Zealand in June and will now test a unique lunar orbit for a future space station there.
Artemis 1 heralds a new era in the history of human spaceflight. It marks a pivotal next step in humanity's return to the moon, ushering in a new generation of astronauts, technology, and research. This critical flight test sets the course for a bright future at the moon. It represents our ability to safely send Artemis astronauts and critical hardware to lunar orbit. Humanity will experience Artemis in different ways than we did Apollo. We will explore new areas of the moon with 21st century materials, technologies, systems, and operations. Gateway will be humanity's first space station to orbit the moon, built with next-generation technology. Gateway will not only provide a deep space outpost for future lunar expeditions, it will also serve as a station for landers, experiments, and supplies. Starting with the core power and habitation elements, Gateway will grow with increasing capability as international partners contribute new habitat and refueling modules, observation windows, external robotics, and more. Gateway will enable longer stays and more science to be conducted on and around the moon than ever before. And one day, it will help set the stage for missions to Mars. A highly skilled, diverse core of astronauts will be selected for Artemis missions, including the first woman and first person of color to step foot on the moon. Aboard Gateway, the crew will conduct exciting research from their unique deep space vantage point. Gateway will also be a transfer station for astronauts to board innovative human landing systems that will ferry them to and from the lunar surface for exciting scientific expeditions near the South Pole. Once on the moon, Artemis astronauts will use expertise in fields like biology and geology to conduct groundbreaking research in modern spacesuits using advanced tools. They will drive new rovers to investigate the lunar terrain and unlock some of the greatest mysteries of our solar system. Artemis 1 cements our capability to send astronauts and cargo to the moon for years to come. We're going back to the moon. We are Artemis.
As we approach the opening of our 2-hour launch window, we have a special musical performance for you. America the Beautiful, played in honor of the flight test by the Philadelphia Orchestra and Yo-Yo Ma. A truly beautiful performance. It really has me feeling quite emotional right now.
Yeah, perfect tribute for tonight's launch.
You know, it's just, it gives me a sense of pride, really, to just remember that our country continues to lead our nation in space exploration. So, and as such, the White House is closely watching this historic launch. Earlier this year, Vice President Kamala Harris came down to Kennedy Space Center and met with NASA leadership as well as astronauts. She also toured our facilities where teams are working on hardware for future Artemis missions. Before leaving, she signed a piece of the Orion spacecraft that will fly on Artemis 3. She's doing it right there, which will return astronauts to the lunar surface. Okay, Kayla, time for more social questions. So let's take the first one. You know now the drill. It's going to be a celebrity question, so let's take that.
Hey guys, I'm Jack Black and I'm super excited for the Artemis 1 launch today. I was part of a little movie called Apollo 10.5, A Space-Age Childhood, and I have a few burning queries. Question the first. How is Artemis different than Apollo?
Artemis is different than Apollo because we're returning to the moon, but this time we're going to stay. So rather than a short visit where we can do some amazing science, but it was pretty limited by these short visits, kind of a small area of the moon, we're going to the South Pole and we're going to learn how to live there long term. So we're going to be building habitats, we're going to have rovers, we're going to have all of this infrastructure on the moon supporting scientific discovery, but also that next big step to Mars.
I love seeing celebrities also take part and ask questions because it really shows that this is something that's captivating a lot of people. So that was really fun to see Jack Black. Also, query the first. That was funny. All right, let's go to the second question. How does it feel in space?
Being in space is amazing. I mean, for us launching to orbit around the Earth and then go to the space station where I just was for 6 months, we're in an apparent microgravity environment. So for us, it feels like we're weightless, like we're floating. So you have to relearn how to live and work in that space. But once you get used to it, it's a lot of fun.
Yeah, we were just talking, Jessica Watkins, another NASA astronaut, was just here, and she was saying that actually when you came back on Earth, that was an adjustment as well because you got so used to living on the space station.
Yeah, the transition home was actually a lot harder for me than the transition up there because our vestibular systems kind of remap. We start ignoring all the sensors in our inner ear that tell us how our bodies are moving because the space environment is so strange, but we really need that on Earth to balance and control our bodies.
Sure.
So when we get back, it takes a couple of days before we feel comfortable again.
Really interesting. Thanks so much for those. Okay, so we are 10 minutes until the opening of our 2-hour launch window today. So why don't we head back over to Daryl. Daryl, tell us what's happening now.
Yeah, Megan, we actually have about 10 minutes before we go into a half-hour hold. That half-hour hold is part of the L clock, and what you see on your monitor right now, I believe, is the T clock. So in about 10 minutes, we'll hold for a half hour, and currently the launch team is trying to evaluate how much of a delay may result from some issues that we've been facing over the past hour. Just to recap those, we had a leak in a replenish valve on the mobile launcher that feeds into liquid hydrogen core stage tank. That's been resolved. The leak has been fixed, and we're moving forward. Currently, the upper stage of the rocket for liquid hydrogen is roughly 78% at the moment. So that is tracking. Progress continues there. The core stage has been topped off, and now both liquid oxygen and liquid hydrogen are 100%, along with the upper stage of the liquid hydrogen side of the equation. So we're just waiting on the complete tanking of the upper stage liquid hydrogen. Now, with regards to the range issue that we had, we just got an update from the range, the 45th Space Wing officer reporting in to the NASA test director that the Ethernet switch has been replaced. This problematic switch took down their ability to see radar from one of their assets, which is key in getting acquisition and signal for the flight termination system if it were to be needed. Of course, this is a critical system that has to be tested before we can launch. So at the moment, we're looking still at a 1:04 a.m. Eastern Time launch, but it is pretty clear from the work that is ahead that it looks like we're going to slip into that window. How much exactly, we don't have an accurate calculation from the launch team as of right now. But of course, we're anticipating that. So for the moment, you see on your clock now, we are in the T-minus 10-minute hold. We just entered that, and now roughly we're looking at 28 minutes to resume terminal count. The launch team will assess what work needs to be done, how that syncs up with the range getting back online with their equipment, and then we should have a new T0 for you soon. That's the latest from Firing Room 1 here at the Kennedy Space Center. Megan, back to you.
So things are obviously still very dynamic. We're going to come back to Daryl as much as possible. Now, to understand where we are going, we have to know where we have been. To do that, we spoke to some of the special few who walked on the moon and those who sent them.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
It's been 50 years since we've been to the moon, and we've got a great program called Artemis. We're going back. The Apollo program was a test for the American people that you can do what you set out to do. All it took was turning to it and making it happen.
We are go for a mission to the moon at this time.
Engines on 5, 4, 3, 2,
All engines running. Launch commit. Liftoff. We have liftoff 49 minutes past the hour.
I think the characteristics that I remember most of the Saturn V was the noise. The noise was enormous and it was almost impossible to communicate.
We're go, swing tight, we're go.
Tranquility Base here. The Eagle has landed.
The landing to me was a great celebration. The nation was almost euphoric.
That's one small step for man, one giant leap for mankind.
There are so many things that we could eventually learn about our universe and the spacecraft that we use exploring.
We are a nation of explorers. During Apollo, we were on national TV literally every day because we were doing something visible that Americans could see and they could feel and say, look what we are doing. And I believe Artemis is going to come up and say, look what we are capable of and what we are doing now.
Artemis will stand on the shoulders of Apollo. They're going to have the eyes of the world on them when they start down this trail.
The science of spaceflight is one that will continue to inspire. Going to the moon generates technology, more communications, more computer technology, more sophistication in manufacturing that help us in everyday life.
We have a generation that is ready, a generation with that technology, a generation with the education. Artemis represents the future in space. It is our next big step, and it is time to take it.
If you're just joining us, welcome to NASA's Kennedy Space Center, where we are showing you a live look of another visitor center. This is the U.S. Space and Rocket Center. Wow, take a look at all of those people who are there hoping to watch the launch today. You know, this is the visitor center for the Marshall Space Flight Center in Huntsville, Alabama. That center played a crucial role in contributing to the Artemis program, so I'm not surprised that there are a bunch of people there watching. All right, so now we're going to take go back to Leah Martin over at Banana Creek. Again, that's right outside of our visitor center, and she's with some other folks who came out to watch today's launch.
Yeah, you know, Megan, we talked about this being America's rocket, right? Every state in the United States has contributed to this rocket, so it should be no surprise that we have people from all over the country joining us here tonight. I'm actually joined by some friends of ours who are joining us from Georgia and Utah. What does it mean to be here tonight to see tonight's launch?
I think it's amazing. I know that tons of people from all over the United States have helped build the rockets and are here tonight, so it's awesome to know that we all have a little bit of personal ties to the rocket.
And go ahead.
No, I'm just excited to be here because I've been a fan of space travel and going to the moon and back, and I'm glad to see it's happening again later in life.
And you were actually telling me a little bit earlier that you grew up in the Apollo era in those years following those first launches, and now here, how does it feel to be watching the sister program launch and seeing at the beginning?
Look at the goosebumps. That tells it all right here. I'm totally thrilled to be here.
Now, and you were actually telling me that you have a personal connection to this rocket as well. You know some people who have worked on it. What do you think it feels like being here? How does it feel for you to see something that's the culmination of so many years of hard work?
Yeah, I think it's crazy when you think about how long it takes to build it and stuff. Like, I wasn't even born last time people tried to get to the moon. So it's awesome. I think it's so exciting, and I cannot wait.
And we have a ton of people who are working tonight still on console. We just want to tell them words of encouragement. What more do you have to say?
Oh, I hope it goes tonight.
Megan, back to you.
Go Artemis.
Woo! Go Artemis. Yes, I love that. And again, I just love these drone shots that we're showing of all the people who are here ready, hoping, anticipating launch today. So now let's head back over to Dan. So Dan is in the Apollo Saturn V Center, which is right next to this crowd that you're seeing here. He's inside there, and he's going to tell us more about SLS using an interactive state-of-the-art tool we're calling the Moonboard.
That's right, Megan and everybody. Welcome back to the moon board. So just to recap, SLS out on the pad, on the mobile launcher. Daryl's been walking you through all of the tanking, all of the preparation. We had that hydrogen leak that was in the base of the mobile service structure here. That's been remedied. We haven't had any issue with those tail umbilicals that we were tracking so closely back in August and September. So everything looking really good with SLS. Just to recap, most powerful rocket we have ever built. It's propelled by 2 solid rocket boosters and 4 engines on this core stage. Now these solid rocket boosters are going to be firing for the first roughly 2 minutes of the flight, a little more than 2 minutes. And we call them solids because of the type of propellant in there. If you forgot it already, it's aluminum powder, ammonium perchlorate, and polybutadiene acrylonitrile. It's a binding agent that's inside. Solid propellants are extremely stable. They're very reliable. But once you ignite them, they're going to keep burning. You can't really throttle them up and down like you can with liquid-fueled engines. You can throttle just based off of the distribution. So you basically put more propellant in some areas and less in others as you're trying to really throttle the rocket down, which we do as we go through things like max Q, maximum dynamic pressure. And just a reminder, as these things are firing, they can steer, they can gimbal. The bottom part here, gimbal just means you can really direct, and they're providing 90% of the steering as SLS is making the flight uphill and more than 75% of the firing at the same time. And again, they're attached to this. This is the core stage, 212 feet tall, the largest single stage we've ever constructed. It's been through the green run test, a lot of preparation for this flight today, and it is propelled by these 4 RS-25 engines. Now these are liquid fueled rocket engines, so you have a fuel and an oxidizer, and one of the great things about liquid fuel is you can throttle them in real time. You could kind of like the gas in your car, you can go faster or a little bit slower. So these throttle up to 104% of their rated thrust at the time of liftoff. We throttle them down as we go through max Q, so the maximum amount of pressure on SLS on the way uphill, and then throttle them back up until they've consumed all of their propellants. And they're consuming that propellant at more than 1,500 gallons a second. That is just an astronomical amount of fuel that's running through these engines to produce that thrust. Each of these up to 500,000 pounds each during their operation. And of all the different components, we've got this engine block section down here. You have all of the associated plumbing, everything to feed those propellants down to these engines. You also have these 2 attachment points here, and that's where we actually tank the SLS rocket. So a lot of focus on those in the previous attempts. They've cooperated spectacularly so far today, and we've been able to fully tank this core stage. And a reminder, you have a fuel, about 500,000 gallons right here of liquid hydrogen, and then an oxidizer. You need those 2 together, and then an ignition source. That's what gives you your reaction, your thrust, your basically controlled explosion that then comes out of those rocket engines. So fully tanked. These are cryogenic fuels, hundreds of degrees below zero, so we've got a spray-on insulation across the entire vehicle. As it's sitting out there in the Florida air, it's a little bit warm tonight, but we need to keep those hundreds of degrees below zero. It takes a lot of energy to do that, so the less you have to use to keep them cold, the better, which is why we have that insulation. So we're going to be seeing SLS take flight for the first time tonight as we clear all of those final issues. Again, this is going to be one heck of a show when this thing launches into the night sky. So with that, send it back over to you, Megan.
If you're just joining us, welcome to NASA's Kennedy Space Center for live launch coverage of Artemis 1. I'm NASA's Megan Cruz, and this is NASA astronaut Kayla Barron. It's been great having you these past 2 hours.
It's been so awesome to be here for this historic launch tonight.
So right now we are awaiting a new T0. The launch team had to work through some issues, and they're doing a great job at working through those issues. So now we're just waiting to see a new T0, since we had been aiming for the top of the launch window, which opened does open at 1:04 a.m. Eastern Time. Now today is a big deal. Apollo 17 in 1972 was the last time humans stepped foot on the moon. That the rocket you see right there behind us, illuminated in the darkness there, is the first step back towards getting us to the moon. Now Artemis 1 is the first integrated flight test of NASA's deep space exploration systems. That's the ground systems here at Kennedy Space Center, the Space Launch System, or SLS rocket, and the Orion spacecraft. We will send an uncrewed Orion spacecraft farther beyond the moon than any of the Apollo missions before it, For Artemis 2, Orion will have astronauts on board as it orbits the moon. Then future Artemis missions will land the first woman and first person of color on the surface of the moon. So Kayla, why do we want to go back to the moon?
The moon's a super interesting place to study. It can tell us a lot about the Earth, its own formation, but also more about our solar system. And we also want to return this time in an international partnership for a permanent presence on the lunar surface that'll teach us everything we need to know to travel onto Mars.
And what about for you? I mean, you have the possibility of maybe being selected for those future missions because the Artemis program can choose from any of you guys, any of the NASA astronauts.
It's a crazy time to be a NASA astronaut and even imagine that that could be real. I think we're all just honored to be a part of the team that's doing this. We're just a small representation of all of the amazing human beings around the world that it takes to do something as audacious as returning to the moon, learning what we need to go onto Mars. So we're just all excited to support the program in any way we can. But of course, a ride to the moon would be incredible. So
Yeah.
I think we're all just dreaming about those moonwalks.
Now, since Artemis 1 is setting the stage for those future crewed missions, is there anything in particular about this 26-day mission that you will be watching? Is it re-entry?
Yeah, you know, we've mentioned that a few times throughout the broadcast tonight. The re-entry is a really important part of the flight, of course, and the heat shield, we're interested in seeing how it performs in real life. We tested it on the ground, but Orion's going to be coming in faster and hotter than any human-rated spacecraft in history. And so we really want to see how the heat shield performs and make sure all the systems can keep the crew safe for that dynamic event.
Yeah, we'll all be watching for that too. It's not just about the launch, a 26-day mission, as we said, so we'll be keeping watch over the entire mission. Our workforce now is very different from what it was during the Apollo era. When Apollo 11 launched, there was only one female engineer in the firing room. Today's launch of Artemis 1 is led by NASA's first ever female launch director. Take a look at how she and other women across NASA are shattering glass ceilings.
When I was a little girl, I wanted to be an astronaut, a scientist, a doctor, a fighter pilot.
When I was a little girl, I wanted to grow up to be strong and independent. When we were asked to draw a picture of what we wanted to be when we grew up, I drew an astronaut standing on the surface of the moon.
All I thought about was when I was going to get to NASA.
It's a huge honor to be NASA's first female launch director. To be the launch director for Artemis, NASA has so many wonderful women pioneers, so many heroes to me.
Some of the most amazing women in my eyes are people like Katherine Johnson and the other women that you've seen in Hidden Figures.
Sometimes it's difficult to believe that I'm on this side now wearing this blue flight suit with all of the other astronauts, representing this iconic image that has so inspired and excited me my entire life.
Being of South Asian heritage, Kalpana Chawla was just such a big thing for me growing up.
I've always looked up to Sally Ride and Mae Jemison, who really laid the foundation to allow people like me to be in the position that I am now.
All of these women were pushing those boundaries and breaking those glass ceilings.
Now, of course, there are some fantastic women in leadership positions that inspire me every day.
We are at Kennedy Space Center.
So much has changed since the Apollo program. During the Apollo 11 launch, we had one woman, one out of 400 engineers in the room. And I look at our team today, it's much more a reflection of the world that we live in.
A big piece of why it's so important to have women and diverse backgrounds, because it allows us to bring everybody along with us on this journey.
It doesn't really matter what you look like. If you've got the brains and you have the knowledge, we need you at the table.
We are at such an exciting time in human spaceflight right now, and Artemis is such a huge part of that.
We haven't been to the moon in many, many years. We have a lot of younger generation folks that have never seen that happen.
We will understand so much more about the moon, about the Earth, about our solar system.
We're going to stay. And to me, that's an amazing idea. The moon is going to be the blueprint for how we go to Mars and out into the solar system and maybe beyond.
It is incredibly exciting to be part of this Artemis team. It still feels pretty surreal to think that I might one day walk on the moon.
To see a woman and a person of color on the surface of the moon, to be able to say that space is for everyone and that we go to space to make life better here on Earth for everyone. I know that tears will be in my eyes.
My message to women and girls out there is to find your passion, whatever that is. Don't let anyone tell you what you can do or can't do. Only you can realize your dreams.
Space for everyone. And if me being in this role helps to send that message, I think that's a great thing.
And I just actually love that I don't feel like a woman at NASA. I just feel like a person at NASA.
The women of NASA are Artemis, and we make a difference every day.
I am NASA's Spacewalk Office Hardware Manager. I'm the Program Scientist for Space Biology.
I'm the Director of NASA's Johnson Space Center.
I am Artemis.
I am Artemis.
私は Artemis です。Yo soy Artemis.
As som Artemis.
Ana.
Je suis.
Ich bin
Artemis.
Artemis.
I am Artemis.
I am Artemis.
I just love the way that that video ends with you and all these other women saying, I am Artemis. What do you think? Why is it so powerful to just hear those three words, I am Artemis? Why does that resonate so much?
I think it just represents how far we've come since the Apollo era and how we take advantage of the incredible diversity our country has to offer. Having seats at the table for everyone, spaces for everyone. You heard that a few times in the video, and I think we're proving that out every single day in our work, not just at NASA, but with our international partners. I think it's so important to our ability to succeed on these really complex missions.
Yeah, I thought that was a very powerful video, and I'm glad that people got that message, young girls in particular. Another person who you saw in that video is Pam Melroy. She's a former astronaut and NASA's deputy administrator. So why don't we head over to Jasmine Hopkins because Pam is there with her now.
Thank you so much, Megan. Yes, I'm honored now to be joined by Pam Melroy, NASA Deputy Administrator. This is just a fantastic night. And we just saw that powerful video with you among so many of the great women here at NASA. What is so important about us now being ready to send, the first woman, the first person of color to the moon?
Yeah, I loved watching that video. Just inspires me. So many of those women are my friends, but also they're just such fantastic engineers and scientists and just so many roles at the agency. I've always thought one of the strongest teams that you could ever find is a family. And families have men and women. And so our teams are stronger, I think, when we have that balance and that diversity. So that was exciting. But for me, I was a part of the Apollo generation, and I was very inspired by, Neil Armstrong and Buzz Aldrin and Mike Collins on Apollo 11 and all the Apollo astronauts. I just cannot even imagine the inspiration, though, for a little girl. I mean, it never occurred to me that I wanted to be an astronaut, but of course there were no women astronauts then. I think what's going to happen now with the Artemis generation is that first woman and the first person of color is just going to have a huge impact on the next generation.
Right. We are just watching with bated breath, and I know that it's going to mean so much to little kids to look up to them. And we understand too, this is a huge, when we launch Artemis, it's going to be a global accomplishment. We have the Artemis Accords, which are helping us make sure we explore peacefully. Can you tell us more about those?
Yeah, it's really important, actually, especially because unlike in Apollo, where it was actually just a few countries that had the capability to go to space, now those capabilities are proliferating throughout the world. And so what we do with the rocket is really important, and how we go is just as important. And how we go is as teams and with our partners, and with a sense of the responsibility that we have as we go out into the solar system to do it peacefully for scientific purposes and responsibly.
Right. Pam, you have a great sense of teamwork, and this is definitely not our first time. There's a lot of things that go into testing out a first-time vehicle. There's actually dynamic activity going on right now. So how does this first flight test of SLS compare to other first times, with Shuttle or with Saturn V before that?
Well, I can do even better as a test pilot,
right?
So there's a history there. In fact, the amazing thing about this is so first flight of a first aircraft, you actually taxi it out to the end of the runway and then run down the runway and come back and check all the data. And then you might take off once and go around the pattern and come back and land. This is a little bit like taking off and going to fly a full mission on your very first flight of an aircraft. And so everything has to be right. So this compares it's very similar to the experiences that all new rocket developments have. Where, it's not just about learning the hardware, that's a big piece of it, but it's also about gelling that team together and your procedures and how you're going to deal with issues that come up, because they will come up. They always come up.
Exactly. And you have that experience as a test pilot, but also as a former astronaut. In that video, we saw you getting your induction into the Astronaut Hall of Fame, which is pretty cool. So what is your perspective, or what advice do you have for the Artemis astronauts, those ones that are going to maybe set foot on the moon?
Oh, well, they don't need my advice. I'd love to elbow them out of the way and go to the moon too. But they are fantastic. I mean, I'm so proud of all of our astronauts. I was just talking to Jessica Watkins, who just came back on Crew 4. This generation is prepared, ready, and excited. And I think they're really excited that we're putting science front and center.
Hopefully they'll do that. And, they said they were going to give it to us at L minus 15 minutes. But at this point, that is kind of a meaningless thing, because we're not, I don't know that we're going to know when we're at L minus 15 minutes, except in hindsight. So we're going to be listening. We're going to be listening to get that poll, and
what do you think?
As opposed to sort of a more nominal countdown.
This is
it might be that when she gives the go to pick up the count, they pick up the count less than a minute later. It could be very quickly from your go to continue the count to when they pick up the countdown. So,
for how we're
like I said, we're not sure when we're going to get the launch team audio, but that would be a good sign, because hopefully at that point then we'll get very essentially real time updates from the launch team about what's going on. So,
going so much more than we ever have before.
And we're just going to have to wait and see when they get to that point.
Of course, go Artemis. Megan, back to you.
Thank you both for that interview.
Yes.
The teams over at NASA.
Yeah, so definitely getting close. And Alex made a good point in the back channel here, saying, that if they were to try and hit the beginning of the window, which, correct me if I'm wrong, is at 1:04 a.m. Eastern, if they were to hit that window, then that poll that Philip was talking about should be happening now. And we have no indication of that happening. So definitely doesn't look like they're going to be making the beginning of the window here.
Little show and tell. It makes me feel like the coolest kid
But
in school.
we do have a few questions here that I did want to hit on.
It is from Apollo 15, 19.
Here we go. So I think we might have hit on this quickly earlier, but we have a question here asking, can you explain what a launch window means? I know we were just talking about launch windows and what time to open and close. What is the launch window for this mission? And why launch in the middle of the night? Why not launch during the day?
Yeah, absolutely. So a couple different factors, but in these types of missions where you're going to the moon, or just more generally, when you're trying to rendezvous with a specific target, whether it's a celestial body or another spacecraft, such as the International Space Station or something like that, you have to launch when the launch site passes under the plane of that orbit. So imagine, or just picture the orbit of the moon as a circle that slices a plane through the Earth. When that plane passes through Cape Canaveral, that gives you your approximate launch
This off. Apollo 15 moon rock. We're looking forward to having
that you can hit. And then based on the relative inclination of that orbit.
You were a cool kid before you even had the moon rock, so. But now you're even a cooler kid. Now the name Artemis was.
And so the performance of your vehicle and things like that, you get some wiggle room on either side of that. So the longest window we've seen on Artemis 1, at least, for that flight profile has been 2 hours long. And the bulk of the launch opportunities in a given launch period are 2 hours. Although if you look at the launch times for other launch opportunities later in the window, not all of the windows are exactly 2 hours. But either way, it comes down to vehicle performance, comes down to where you're going. Can also come down to things like range availability. I mean, it's not practical to keep the range closed off for a launch event for 8 straight hours or something like that. As much as that might be accommodating to the mission, that's closing airspace in the area. That's committing range personnel to being on console for eight plus out, more than 8 hours realistically. So there are other factors that influence how long you can basically reserve for a launch attempt. But the driving factor is physics. And while the team would definitely prefer to be launching in day, I know we've talked about this before, because that gives you some extra imagery, gives you some extra data in that sense, especially for a test flight like this. The fact is, it's not worth delaying the mission significantly until the moon is in the right place where you can launch during the day, to postpone this test flight. They can get a lot of data already, even without daytime views, and the NASA teams have all pretty much unanimously agreed that that's not an issue that would prevent them from taking these launch opportunities, even though they're in the middle of the night. Comes down to every mission. Operational missions will have even less constraints. Test flights also have extra objectives and things to make sure you get as much data as possible on that first flight before you move into the more operational missions.
Yep, there you go. And it does look like we have an update here, given to us in the back channel that upper stage, which is that ICPS liquid hydrogen, is now topping. Also, the range safety officer is testing the flight termination system, which is that system that will terminate the rocket during ascent if anything were to go wrong. And then one more thing, the launch team is currently determining a new launch time for the rocket. So, of course, we've had those delays that have pushed back the launch into the window, but it looks like they might be getting ready to figure out when they're actually going to launch this thing, which is super, super, super exciting. Going to keep it going here with some questions. A good, interesting one. I know we had it up on the screen a few minutes ago, but Jay asking, what is the advantage of a mobile launch tower rather than a fixed service structure at the pad? Of course, SLS rolled out with that mobile launch tower, which is that tall tower behind it. But during the Saturn V era, Philip, I know that there was a fixed tower, or actually, no, there wasn't. But during the shuttle era, excuse me, there was a fixed service structure at the pad. Why didn't they opt to do that with SLS?
I mean, I think I think it. Part of the reason is, looking at just you want to minimize the amount of time. You see this with with other service providers, and the SpaceX is kind of flexible, but they have depending on which pad. So pad 39A, they have a fixed service tower there, but it's probably used mostly just for crew access. But I don't believe that I don't know how much of a fixed service tower that they have at Pad 40, for instance, or at Vandenberg. And so the thing about having a large tower that's out at the pad all the time is you have to keep service and maintenance on it, and it's out in that salt spray 365 days of the year, and there isn't that much of a reason to do the checkout and maintenance of a rocket outside. And so they were really hoping with this vehicle, and I know we have a launch control update coming here, but the idea is for this, they wanted this vehicle, they wanted to test and check it out in the VAB, roll it out and launch it. And so it's taking them a long time for this one, but eventually they would like to be getting to a point where they're basically only out at the pad for about a week. And so basically they're just launch controls confirming that they aren't going to make the opening of the window, because we passed that point now by a couple of minutes. And so they are, obviously going to stay. They're going to keep the clock holding at T-minus 10 minutes, and they're still estimating how long it's going to take. Upper stage being in topping means that they're very close to getting into replenish, and then it's a question of how long they need to stay in replenish. And then again, they're testing that range system that transmits the commands to the flight termination system. And so it's just a question of how long is it going to take to finish, get the ICPS ready, and how long it takes to finish and get the range computers ready. So we're waiting to hear. I guess we're still waiting to hear when they say they're extending the hold. That means that they don't know what the new T0 time is yet. So we're still waiting to see how long it's going to take. But just again to remind everybody, we have 2 hours. So the launch window runs from 1:04 a.m. Eastern to 3:04 a.m. Eastern. So we haven't reached the T0 time yet, but they would have to pick up the clock 10 minutes before that. But we still have 1 hour and 57 minutes of window to work with here, and so they can launch anytime all the way up to 3:04 a.m. Eastern, which is 8:04 a.m. UTC.
Now, quick question, Philip. When they go ahead and start courting a new T0, do they just do they command a release of the hold, or do they select a T0 time and then the hold gets released accordingly for, in this case, 10 minutes beforehand?
Good question. I think the way that this system works, that they can put in a resume time for the ground launch sequencer, which is going to be controlling the most of the final 10 minutes of the count. Because what happens is down at 33 seconds when they do that handoff, if when they get to that point, the ground launch sequencer will then give that T0 time to the rocket, to the SLS flight computers, and so it doesn't do that until the handoff. So you could pick up at 10 minutes, for instance, and count down part of the way, stop, hold for a few minutes, and then continue and resume. So they have a little bit of flexibility there, and so again, if we get close to the end of the window, which hopefully we don't, these issues, at least at this point, don't sound like it's going to take the entire 2 hours of the window. But if they got into a time crunch, they could pick up the clock relatively quickly. I think the issue, and they used to do this in shuttle, would be if they were getting into a time crunch, those polls that we talked about, they would basically get those essentially almost all the way out of the way. They'd basically pull the entire launch team. And if there were, if we were talking about, again, like the upper stage and range, they might just leave those two open, make sure everybody else was go. And then as soon as those two positions reported they were go, they just pick the clock up. I don't think they're going to do that in this case, but they could pick things up and go in a hurry if they needed to. So, but this is going to be kind of a seat of the pants, do this relatively quickly. So I'm kind of hoping that we'll get the launch team audio here, relatively soon. I think I'm probably being too optimistic about that, but I think that's kind of, they'll play it based on how much time they have left in the window. With 2 hours, they can go at a little bit more of a relaxed pace.
What could you do with a metal 3D printer? Introducing the Metal X, the easiest way for you to go
on how far we go with these problems. They're not going to have enough time to recycle tonight. So now that doesn't mean that they're going to be forced to recycle. So it's just a question of, I'm sure they would take it. If they got down to the end of the window and they only had one shot tonight, I'm sure they'd take it. So I don't think they're going to necessarily worry about whether there's a potential for a recycle. It's just a question of, we're still just waiting to hear when they're estimating the new T0 time, and we'll worry about the rest of it. But I also do think what they have left to do in terms of polls and things like that before they pick up the clock, they're probably not going to waste a whole lot of time on that. They're going to try and do that as quickly as they can.
Yeah, the other factor to put into all of this, and this would have been some information that the team would have actually received yesterday, I believe, is launch cutouts. They have times throughout this 2 hour window where
that's a good point.
There are collision on launch assessments, or COLA window, where basically the launch trajectory would take some parts of the spacecraft too close to vehicles that are already on orbit. Most of those cutouts last, like a second or two, because things moving at orbital velocity get out of the way pretty quickly. For things that are larger or higher risk, such as the International Space Station, sometimes a COLA window can last a minute or two. They're pretty small cutouts, and there's only a handful of them throughout the window. So when they're looking at new T0, they will not only evaluate the readiness of the vehicle and the teams to pick up the countdown, but they'll also see, okay, if we're going to get ready to be resuming here, when we reach T0, are we in a colo cutout? And obviously, if they are, they'll just push it till the after that cutout window. So they'll check those as well.
Right, and I believe actually that they have the capability in the software to load all of those colas into the software. We were told, I think there were something on the order of about 56 of them, and like you said, they range from a couple seconds to maybe a minute in duration. But they can load those into the ground launch sequencer such that if they wanted to pick up the clock, they could basically put that command in, and then the software would figure out when's the next possible time I could pick up. So, if you were to have some colas kind of stacked up in a short period of time, like within a 10-minute space of time, then they will obviously they will work with that. They already know where those are, and they'll look at those before they were to consider picking up the clock. So if there were a period within this 2 hours where you had a sort of a knot or a bunch of these cutouts, they would probably just look to push to the other side of that. So, but that is a really good point. And so yeah, they have some of that already sort of prepared. And then some of it they'll just they're probably looking at that right now, and they already know, okay, if we get to this point in the window, then we'll just, we'll just hold to the other side of that. So, but we're probably only talking about a few minutes, and it might not even be a consideration yet.
Definitely. Well, the farther we get into the night, the closer we get to the launch of this thing. And as we've been doing throughout this entire stream, we have a whole team here that's helping us, swapping in and out and helping with comms. So we have a familiar voice joining us here. You probably heard them earlier on stream, here and there throughout the stream. Chris Gebhardt, Assistant Managing Editor for NASA Spaceflight. Chris, how are you doing? I know you've got to be like just shaking.
Well, we did my baseline heart rate a few hours ago. It was 65 beats per minute, and when I just checked it, it was 113. So my body is transitioning for terminal count. I can tell you that. And Jack is at 115. Oh, we're heart rate buddies. Nice. But yeah. So. I know I know they're testing the connectivity of the rocket with the range right now after the reset, and we're going to be aiming for a new T0 here within the window. But I'm excited. I'm nervous. I'm feeling all of the real thing. I really didn't expect. I didn't expect it to feel exactly like shuttle when it was in its T-9 minute hold, and it feels exactly like that. The butterflies, the not knowing what to do, the legs shaking as you're getting close to this. It is just you're just getting ready if you know what's coming for that very, very visceral experience once the RS-25s and the solid rockets ignite. And I am definitely my excitement is definitely arcing, and I'm sure you can hear it in my voice.
I can't wait
certainly can, and I can feel it sitting next to you. I do get just a quick word also from our live stream production team that they have had their final debrief on the launch sequence for today's broadcast. So I'm going to leave you on the capable hands of not just Chris Gebhardt, but also Hagen Warren and Philip Sloss. They are our liftoff commentary crew for the launch of Artemis 1, hoping to get a new T0 here shortly, and we'll be watching from here at the press site. Stay tuned.
Yes, thank you so much, Thomas. Of course, that's Thomas Berghardt, news director here at NASA Spaceflight. He's out in the field at the press site near Launch Complex 39B, where SLS is currently standing, as you can see there. He's been with us throughout the night answering questions, and he's getting ready. He's hopping off stream to prepare for launch. This count, Chris, really seems to have gone a lot smoother than the others. It feels like we've had less issues feels like we've had less issues with this. You know, knock on wood, don't want to jinx anything, but really, it feels like they've really nailed down the process here through the last few attempts.
It really, really does, Hagen. And one thing that I'm sure we stressed on the stream, and that I just want to say too, is like the valve that was sort of giving them problems a little bit earlier, that they had to send the red team out to go remove and replace. Hey, if that's all we got, and that was the biggest issue from the actual ground systems at Pad B, that's incredible. Range issues happen. It is weird that you could talk about an Ethernet distribution box being the issue that could delay you, but the range has had issues before. The final flight of the shuttle Discovery, STS-133, had a massive range issue that resulted in them launching with 1 second remaining in the launch window. So range issues do happen. They are rare, but they happen. So, the fact that they fueled the core stage with no major reported issues is wonderful. The fact that they got the tank back into its propellant, it's really working good so far. I agree.
Yes. All right, we have a few questions here that I've been pulling from chat. Of course, as I mentioned earlier, if you do want to ask us a question, especially as we get closer to the end of the count